In the last class, we discussed 5E. Today, we're discussing 6A, and this is titled Characterizing Data. So today's discussion is about 6A. To give you an introduction, we are learning to describe data or to characterize data. We will discuss a few new concepts in order to do so. So this is the beginning of Chapter 6. Throughout Chapter 6, we're going to develop our skills. To begin, we're learning about measures of tendency. So the 3 measures of tendency we'll discuss today are mean, median, and mode. We will also discuss distributions, and that will include variation, so the variance in data. We will talk about the number of modes. We'll do this, I will only discuss this briefly in class, but you will see this in your homework. So the number of modes, and then symmetry and skewness. So these are our main ideas in today's lesson. When you hear the word average, sometimes that is used colloquially just as something that is typical. So today we want to talk about average a bit. If something is average, in math classes, often you're taught that the mean is the average. However, if you're using average in the way that it could just mean typical or what is common, then that could lead to confusion. And so to begin this section, we're going to talk about the confusion that could arise because average is not clearly defined in a paper or in a data discussion. So when you hear average, in this section, we really want to clearly nail that down as to what is what are the formulas or what are the numbers used for the average there. And so to get you thinking about that, I have a somewhat silly slide up here. I want you to imagine a neighborhood. And in this neighborhood, most of these homes are tiny homes. So we have a couple cute tiny homes. Those are popular lately. A little less than 16,000. 13,500. This one hooks up to a car, so it's a little bit more, 21,000, etc. And then also in this exact same neighborhood, can see all these tiny houses. There is a $5.8 billion home or mansion. In this neighborhood, if we were to describe average, I want you to consider that the confusion that could be involved with that, and whether we mean by average what is common, or whether we mean the actual mean, so adding up all of the values and dividing by 7. And to think about those numbers, I've gone ahead and calculated those for you. We'll talk about mean more today, but you probably have already worked with mean at some point in your math career. Mean is simply the calculation. It's the sum of all of these homes. So I add up all homes and then I divide by how many homes there were. When I do so, I get $966,681,050. That is the mean here. We don't want to use mean for the average home cost in this neighborhood because $1 billion does not describe the typical home in this neighborhood. If we look at median we'll talk about more, but to find the median, we order all of the costs of these homes from least to greatest or from greatest to least, and we find what is exactly in the middle. Our middle two would be this 18,500 and 17,500. Directly between those would be our 18,000. So this silly neighborhood is to get you thinking about the confusion that could arise when we say average, and here mean. Though mean is often a synonym for average, mean is simply not an appropriate value to describe this neighborhood market. Whereas if you consider the most common type of home would be these tiny homes, median might be more appropriate. Now, this was a far-fetched example, but we do see this in real life frequently. And so now I want you to keep an eye out for it when you are reading the paper, reading online articles. You'll often see when we describe home prices or salaries, we use median instead of mean. And so these are from the fall last semester. These are just a few articles that I just pulled up quickly on the news. And the real estate market during the pandemic was kind of crazy. So prices were escalating, and you can see that this article is describing Housing prices in Bozeman using median prices, median income. So when we describe income, we often use median, and then down towards the bottom, hourly wages. These are all examples of using median to describe data because it can be in a more appropriate description than using and calculating the mean of some data. And the reason why, if we're ready to get into that, is because this group of data, though this was far-fetched, the extreme value here was what made the mean so different from the median. And this is an example of an outlier. So you maybe heard that before. An outlier in a data set is a value that is extremely higher or far lower than most of the other values. Outliers can substantially change the mean of a data set or the correlation among variables. So they can significantly alter the mean so that it might not have an appropriate average. It might not be an appropriate way to describe the data. In data, I want to mention this. You won't work with, so I have a scatter plot here. You won't see this in your homework, but you might come across something like this in chapter 6. When we graph data, software will actually kind of notify you of potential outliers. And I've circled these here. When I was running, this was some recent survey data that I was working with, and I clipped a photo from my work to show you all that the software was trying to alert me that these seemed like outliers. These were actually data entry errors. So one of these was extreme because the age was incorrect. It was something like 118 years old, which obviously couldn't have been the age in the survey data, or most likely wouldn't have been. And so that was considered an outlier. So the software will often make an extra little circle above, or maybe label that to alert the user that you have an outlier. So outliers, again, are those values that are extremely higher or extremely lower than most of the other values. They can significantly influence your data. So here, having those 3 outliers was really messing up my linear model for the survey data. And so removing those, in this case, improved my model substantially. So this is to get you thinking about outliers. Then we'll wrap up the discussion about measures of central tendency. So the 3 measures of central tendency that we wanted to focus on are mean. This would be the sum of your values divided by the number that there were. So with the number of homes, I added up the 6 homes and then divided by 6. When you calculate mean, I gave you a silly neighborhood so you would consider the fact that that mean was susceptible to outliers. The $6 billion home was an outlier when you considered all of the tiny homes around it. And so the mean was significantly susceptible to outliers. Due to that reason, it's not always an appropriate measure of central tendency. So median can also be used to represent average or typical values. To find the median, most likely most of you have done this, but just to remind you, you order the values, find the middle value. If there are an odd number of values, you will simply take the mean of the middle 2. Medians are not as susceptible to outliers. They are a very appropriate measure for central tendency for things that have extreme outliers occasionally. So things like income, housing prices, salaries, anything that deals with money. Median is often a more appropriate measure of central tendency. Mode, the 3rd one that I haven't discussed yet. Mode is often a useful way, to describe data as well. It's more beneficial when we have qualitative data, though. So mean and median are used most of the time when you have quantitative. But mode, if you had options on a survey, like yes, no, or an uncertain, mode would be a more helpful measure of central tendency because you're using those categories. The mode is simply the most frequent value which occurs. Occasionally, you'll be asked for mode when you do have quantitative data. Math books often do that, but I just want to remind you, in real life, mode isn't necessarily so useful for quantitative data. It is useful for qualitative data. Your homework is just going to have you practice the idea, and that's why you'll see that with the numerical data.